What's up, everyone? How we doing? Welcome back to the Routing Loop. I'm Matt Lewis, and we've got James Wenzel. How you doing, Jamie?
I'm doing well. How about yourself?
Pretty good. I don't think I've ever called you James before.
Yeah, it did sound kind of weird coming out of coming out your mouth, as they say. It's like, call me James. Get that name.
It's either Jamie or Wenz, I think. Yeah, funny.
Yeah, typically.
Actually, growing up, everyone always used to call me Lewis because my last name was kind of weird. And so it was
Really?
like people met me and then they found out my name was Matt and they're like, "Oh, your name's Matt? I never knew that. We just always call you Lewis." Go
That worked.
figure.
For me, it was James is my name, but my mom had called me Jamie because she hated the nickname Jim. So she would just say that.
Wow.
And of course, as a young lad, I would be quite embarrassed being called like a baby named Jamie until I got a
Yeah.
little older, and some of the young ladies thought that was cute, and then I was Jamie forever.
Did you introduce yourself as Jimmy ever? Hey, I'm Jimmy.
Never. No, 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 no. You do not want to incur the wrath of my mother. That is not something you want to do. It's not wise.
I might start calling you Jimmy.
Yeah, there you go.
So this is Matt Lewis, and we've got Jimmy Wenzel on the routing.
Thank you.
No, it doesn't have the same ring
It
to it.
doesn't. It
So
doesn't.
what
Matty
are we
Lou.
talking about today? We've got
Um.
intro to network security, right?
Yeah. Networking security. We're going to talk a little bit about. Well, we're going to draw. I think. Right. We've got the whiteboard to do some drawings,
You have the
and
whiteboard.
we're just
Yeah.
going to talk about kind of practical security with networking. And in my mind, and let me know if you think of anything different. And hey, Ken, how you doing? Hi, Yuri, how you doing? If anybody else also in the chat has any ideas or thoughts about this as well. But I always look at security with networking from two different vantage points or two different lens points. One of them is what I call peripheral security, right? So it's kind of like that fence around your yard. So in the front door, you might have a firewall, right? Or that's literally your front door in your security system. You might have cameras like probes and stuff all around the outside to see who's walking in, walking through. And you may have like physical restrictions like hallways or doorways, right, are restricting where you can go. So that would be like your routing in your logical routes. And that's all handled on the infrastructure level. And then the other part of security, which is I would say is still emerging, is this concept of built-in security or application networking security. And this is where you're getting your identity offloading. This is part of it is TLS, right? Doing like your encryptions and whatnot, authentication offloading that you can do, like say with API gateway or application load balancer, where you can have it handle all of that stuff for you. Plus doing validation at the application layer of like your headers, tokens, all of that. You can see that with things like VPC Lattice, again with our load balancers. Um, and then just that general overall um, part of the application security as opposed to the peripheral security. And I don't know about you, Matt, but do you see any other areas of security that I maybe have missed in that
No,
description?
I think your I mean, as per usual, your understanding and kind of way of describing things is pretty much aligned with the way I think about things. I guess to really simplify the way I think about security, I think about access security, and I guess it's data security or data. When you think about control plane versus data plane, I think data plane security and control plane security, right? Just splitting into those two pieces. What we get pulled into a lot is what I think, and correct me if you have a different understanding of this, but it's really data plane security, right? Because we're
Right.
networking first. And so it's, hey, we've got these communication flows and data flowing through a network, but we want to add some policy control around that. We want to add some security. We want to have some firewall rules. We want to have some observability. And it's really doing things with the data plane. The control plane, I'm actually admittedly terrible with control plane security, things like IAM and locking down
Sure.
accounts and, different. Actually, one thing I do want to talk about, and maybe we can throw this out, is like, how do you set up an account with like VPC sharing and multiple VPCs and applications, and what does a security model look like from
Sure.
some folks will have a single VPC with many applications in it, with many subnets, or others will say, hey, well, let's have many VPCs. And how do we do security in those two different models, right? And so I think that's where I get dragged into the control plane security on setting up accounts and other things that get a little squirrely and uncomfortable, versus data plane security and securing traffic flows is super easy and second nature to folks like us, right?
Right. Well, if you think about it too, Matt, like when we used to ride to work on our dinosaurs back when it was like a data center, right? The main part of that security was literally the swipe getting in the door. But now that you're in the cloud, that's where the IAM security is kind of replacing the swipe. And I guess if you're going to go
Right.
on a more micro level, yeah, that is applicable with VPC sharing. It's a different way of kind of locking things down where somebody can set up a network or a VPC subnet and then share that out and have other people use it according to the rules that they set up. So I guess that's another form, but it's nuanced, I suppose.
Yeah, and maybe it's just what stage of cloud deployment are you in? I'm starting out.
True.
What do I do? Do I have a single
Right.
VPC or many VPCs? Or are you stepping into an environment where someone says, we got 200 VPCs and we've bought a couple of companies and we've got a whole bunch of different data flows, and our security policy says that you shall have a firewall in line for all data flows. The next
Okay.
question should be, well, what constitutes a firewall? Oh, we have a list of approved vendors. Or actually, it's we need stateful rules. Or no, we need just some form of network access control so we can block things. It depends on what each person's definition of security for that data path is. And depending on that, depends on what your architecture really ends up being, right?
Yeah, no, it's true. It's a good point as well, because I've been working with a couple of customers. As everyone knows, I've been beating the VPC lattice drum along with some other folks because it's just a different way of connecting things. But within that construct, right, with lattice, there's really no way to insert a firewall. Because of the fact that it has those VPC endpoints where it attaches, and those are 169s, and it's doing that whole usurping the FQDN from your service and then shoving all the traffic in there, basically natting it all out. But inside VPC Lattice, it uses IAM for policy control. So one service getting a role, right, and having a policy attached to it can communicate to another service, and as long as the policies match and the roles match, they can talk. I've seen customers actually take those policies out and export them and give them to their auditors and saying, this is our firewall. And they're not wrong, right? Because what is the major difference between IAM locking down your data path and your control path through the control plane versus, like, say, a Palo Alto or a Cisco ASA?
Yeah, I guess it does come back to every individual organization's definition of that security. And like some folks, I'm trying to remember in my very brief DoD, Australian DoD, not US DoD days, where there was things like impact level, IL5, I think it was. And as part of that IL5 assessment, there was an approved list of vendors. And it was like, oh, Palo Alto, for example, did the work to get approved and on this list. Do we need to deploy Palo Altos everywhere? Well, that's what this checkbox says, right? We're
Yeah,
ticking
yeah, yeah.
a box for a third party or tertiary certification that we need to appease, right? And I do think that when customers started using AWS, the first thing they defaulted to was like, hey, like I've been using those firewalls forever. How do I just
Right.
have those in line? And I think
And
I
you
think
know
that
that those
earlier, like,
firewalls satisfy InfoSec, like, which is one of the hardest
exactly,
things to do, right?
right. Yeah, they meet the criteria. I think it was an impact level criteria or an approved criteria. Someone can in the chat can confirm the real terms of what that is for those folks. But I think we did see some unnatural topologies, and we'll get into drawing data flows and topologies in a second. But we did see some unnatural topologies where folks were deploying physical hardware on premises, and like a physical firewall that they may have already had or that they bought, and then using a direct connect to go from VPC to on-prem
Yes.
back to VPC. Right, so they want to go cloud to cloud, but they're going on-prem, and then it's like, well, hold on a second, we've got an extra 20 millisecond one way, so 40 millisecond one way because 20-second to on-prem, 20-second back,
Mm-hmm.
just to go through this set of firewalls, not including the time it goes through the firewalls. And we're paying umpteen tens of thousands or hundreds of thousands of dollars for physical equipment and racking and power and
Licensing.
space and everything else, licensing and everything else that goes with it. But that was a comfortable architecture. It made a lot of sense to folks that say, well, we've got this security infrastructure that we know and love and trust. Let's send all traffic through that. And I
Let's
think we
hairpin.
still see that today sometimes. It's a little better when we start talking about firewalls in line in AWS and things like egress security VPCs and transit VPCs, and transit gateways helped with that. Network firewall has helped with, folks that say, I don't really particularly care for a specific vendor and I just want some bare bones capabilities. Security groups and NACLs have always kind of been there in AWS, so they work as well.
Right.
There's a lot
I
of
will
different
say
options, I
though,
think.
there is a hairpin part two though that I've seen, right? So that's a good point. I actually was on a call not too long ago that they were still doing something very similar to that for what was it, IDP, right? Where they're basically inspecting their packets on-prem with a homegrown packet inspection device, Linux box, probably using Snoop or something like that. And it was like one of those things that their security only allowed. So we had talked about moving that into the cloud because it was Linux based, and we did, but we kind of just shifted the problem where they created a new VPC, an inspection VPC on a transit gateway. So instead of doing the 40 millisecond drag, if you will, to on-prem and back, they were doing a 4 cents per gig transaction every time they talk to any other VPCs, or in some cases talk to other subnets in their VPC, because it was dragging it out of the transit gateway into another VPC and then back through the transit gateway again, 2 cents per gig out twice, and then back. So I've seen a shift. Have you seen that too, where folks have been doing that?
It depends. There's a crossover point. I did the math on this a while back when we were looking into different functionalities that we would build into maybe a NAT gateway, for instance. And one of the peculiarities was you could build a firewall and have an IGW in every VPC, 1 VPC, 2 VPC, 10 VPCs. Or you could have a firewall and an IGW and a NAT gateway or whatever else in a central VPC and go through the transit gateway, like you just described. You pay an extra 2 pennies per gig data processing. And so it depends on how many VPCs you have versus how much data you're transmitting to which one is the more cost-effective solution. Is it better to have per hour charges in every VPC and pay for licensing for a firewall in every VPC? Maybe if there's a couple of VPCs. Or if you've got a central VPC, you pay much less because you've only got one set of network functions. Now,
Sure.
so it depends, but if you start sending a lot of data bandwidth, those processing charges on the transit gateway start to really rack up, and it becomes more effective to move back to a distributed model. So it really depends. Like, we see all sorts of different things, and we don't talk about future roadmap stuff here on the routing loop. Unfortunately, I'd love that. That'd be such a good session if we could do that. But
cool.
we are thinking about how do we help with that, and I would love to see things like multi-attached network function things, or maybe something like that to help with those kinds of architectures. And I think transit gateway and cloud WAN are 2 really great central components in your AWS network that makes a lot of sense. And we just did service insertion for cloud WAN, so you can kind of see the direction that we're heading, right? That helps to have firewalls in line for network segments with cloud WAN. Maybe we can draw that one out too. But I'd like to make those topologies far simpler. Like, that would be amazing.
That would certainly help. And cloud WAN, to a degree, and transit gateway, even in and of themselves, again, with the amount of control that you have over routing, segment attachments, right, and who can talk to who, logically, in and of themselves, become a security device as well. Again, going back to that perimeter level security that you can configure. So not only can you do the service insertion, which is the ability to say, if I want to have one of my segments talk to another segment, force it through an inspection or through something else, and then basically send it back like you would in a transit gateway scenario where you have a security VPC, send something to the security VPC and back. Very, very simple to do, which is nice. I see a couple of things we have out here. Ken is basically mentioning not network related, but SCP, RCP, which are the security control protocols, makes miracles for control panel security if properly set. That is great. That's a good point, Ken. There's so many facets to security just outside of networking, but one of my favorite facets is inheritive security, right? You'd see that mostly also if you're using NACLs or NACLs, as we like to call them, where when you launch something into an environment, it inherits that security of that environment. And that's where those security control protocols that you get with organizations do become so powerful. And then we have, I'll give this question for you, Matt, because I know you're a lover of this.
Is Transit Gateway still the king? If Transit Gateway was the king, I'd say Cloud WAN is the queen. I do think that we talk to many customers, and many customers are using just Transit Gateway to act as their central hub for their VPCs and building Transit Gateway networks across regions. Hierarchical Transit Gateway architectures are popular as well, where you have transit gateways in the same region peered to each other, and you say, this transit gateway is for that business group, that
Right.
transit gateway is for another business group, and you split things out and connect them via a central transit gateway. So yes, a lot of customers are still absolutely using Transit Gateway. Does Cloud WAN make things simpler and easier? I think so. Believe it or not,
yes, at scale. I would put in the caveat
scale.
at scale. If you're
Okay,
using
that's fair.
1 or 2 regions, right, and you don't have any plans on expanding beyond that, Cloud WAN still could be great, but you are going to go, I believe you're going to go through some extra steps.
I think it, like, once you get to many VPCs in many regions, Cloud WAN makes a lot more sense. But then you've got to go, hey, I've got transit gateways. How do I move to Cloud WAN? Which is actually that move is quite simple compared to what you would imagine. You can attach transit gateways to Cloud WAN and move VPCs from a transit gateway attachment to a Cloud WAN attachment pretty easily. In a change window, you're changing routes inside of VPC, but it's actually pretty painless. I think we might have a couple of blogs maybe we can find on migrating from transit gateway to Cloud WAN. To answer the question, I personally think that transit gateway is still the king, but we do see a lot of customers taking advantage of Cloud WAN and all the value add that it brings to the table. So,
and transit gateway is a building block of Cloud WAN, right?
It's still the data plane. Yeah, you're still using transit gateway under the hood when you're using Cloud WAN as well. So we're using that same technology. Yeah. So we do have I guess a contract with our audience here on best practices for securing your network. So maybe we should start drawing some stuff and talking about some best practices. Maybe some tips there on things to follow.
So
that face always cracks me up every time that comes up.
I mean, you drew it, so it should.
Yeah.
All right,
it's just to orient our iPads and screen share and know where we're actually drawing, so we know where we're
just
actually
to prove for completeness, it actually does exist on my iPad, right?
Yeah, there you go. Nice.
All right, you want me to start drawing that, or you want to start drawing?
Yeah, go for it. Yeah.
All right. I'm going to erase this out. So let's actually bring up the one point that you had that was really, really good, or at least I thought was really, really good about. Let's start with inside VPC security, right? And then we can just kind of branch out. Is that a good place to start? Because most of the things that we do,
I always start with the VPC.
Almost everything we do in AWS is always at least at the very, very minimum on an AZ, which is in a VPC. So let me draw that out. Let me make sure that I got my line weights and everything all good, so everything looks good. So let's see here. I like the freehand draw more. You guys like the whole everything automatically turns into a square. So we'll do our standard.
And maybe on the screen share, let's zoom right in so we have like the whole thing taking up the whole.
Yeah, I gotcha. Is that too much?
You folks tell us. We can zoom in a minute.
Yeah, you guys tell us. Is this good or is this not good? So I'm going to start with the standard 2 AZs, right? We've drawn this before, where basically these are the AZs, and I'll just label this right here real quick, VPC, right? And then I'm going to just do a different color for our standard red for our internet gateway. So I'll just label this as an IGW, right? And this will go out again, red, not trusted, and we'll call this the internet. And I know that's a little bit off screen, so I'll just adjust that just a little bit, because if not, Matt will complain.
There's nothing interesting out in the internet anyway.
Yeah, nothing interesting. And then, of course, we launch our EC2 instances, and I'll just do our EC2 instances in our standard Amazon Orange. They could be clusters, they could be individual machines. So the first thing that we can talk about with inside, right, AZ is obviously security groups. You brought that up before, Matt. So like everything that you launch inside of an AZ will have a security group, right up to now, to the point of Network Load Balancer, which was released, I think, 1 or 2 years ago, 1.5 years ago, where Network Load Balancer had
I don't know when Network Load Balancer was released. Maybe someone can post in the chat. I know Gateway Load Balancer,
security groups,
Firewall released in 2020, but
Oh yeah, yeah, yeah. So we've
But
got
that
the
was
security
after
groups
NLP.
here. And I know that's a little messy, but we've got our security groups. It's in red. It's protecting ourselves from internet traffic, and it's our stateless or stateful form of security. So anything that you allow in will also allow it to respond, right? And then we have our NACLs. I usually draw those in green, and I'll do this in a different color too. Just so you know, I'd like to make a complete mess of my drawings. And on the outside of our subnets, you have the option, if I want to do on the top, of creating a network access control list. And a network access control list is stateless, and it applies to everything that gets attached or gets launched into that particular subnet. And remember, you can have multiple subnets on an AZ. So it'll inherit that security, and you have to be very explicit as to who you can allow in and allow back out. So you want to be very judicious as to whether when you want to use those network access control lists versus when you want to use a security group. Because if security groups, you can pretty much maximize your usage a bit more. You can associate them, you can nest them, you can even reference them now across transit gateways, right, Matt?
Correct. That was a
And you can do it.
long-standing feature. Yep.
Yep. You can do it across a peer, so you can take advantage of that. But when you're doing a network access control list, those are bound to those subnets and everything on that subnet, and it's kind of set in stone when you put it in there. Granted, you can change it, but when you make one change in the subnet, everything on this subnet, is pretty much going to be affected by it. So that is like the simplest form of security that's baked into a VPC. We have other ways of operating within a VPC, which would be more secure. Like we can put in ANF, right? Firewalls and all that stuff. We can also do things like endpoint services so that we can have secure unidirectional flow connectivity back and forth between VPCs. But just as a base for a VPC, not using sharing yet, because I know you talked about sharing, Matt. This is some of the very basic ways to just kind of lock down that VPC. Any comments on that, Matt? Anything else you want to add about just
Yeah,
basic
I think
VPC hygiene?
this what we have here, and I'm just struggling with our drawing tool here, but it's all good.
I'm sorry. Say I like picking
No,
Miro
that
because it makes Matt, a little uncomfortable.
I'm like, okay, where's the eraser? That's not the eraser. That just drew a weird box, and I don't know how to delete it. So what you've got here is a single VPC, and I think that's totally fair and totally okay. Now, what we can do, what happens if you want to have many of these VPCs? Or do you put everything in this same VPC and just repeat this model? Or how do you
Well,
get to
that's
the internet? Do you add an internet gateway and then, oh, that you do, that's not a TGW, that's an internet gateway. So this is,
yes.
oh my God, I'm just drawing random lines here. You've got
I like it.
let's change up the color here, and then I'm going to change up the
Thickness.
thickness. Okay, so you've got this internet gateway here. It's attached to the VPC. Now, the EC2 instances that are in these subnets, let's just say they have a default route via the IGW. Now they have unfettered access to the internet outside of security groups and NACLs. Is that okay? I mean, is that I mean, some customers are totally okay with this topology, right?
Yeah, but I mean, to be very honest with you, Matt, most of my conversations with customers are to stop that very thing.
Okay. Okay, so with this topology as well, and one thing that's interesting is this EC2, if we want to zoom right into that top right-hand box where I am right here, that EC2 is privately addressed with a 10.0.0/16, or actually there's a /24 subnet, and this might be a 10.0.0.5, right? It's still private addressing, but to talk to the internet, you need to give it a public elastic IP, which isn't actually on this instance, by the way. It doesn't get associated with the instance. It's a NAT further up on the IGW of a 54.10.5.2 to the 10.0.0.5. So are we coming up with best practice number one, in that this topology is okay if you want public reachability directly to the instance from the outside? What about if it's just coming from the inside? Is this still a good best practice to just give public IPs to EC2 instances? Maybe if you want that, I guess.
What do you folks think? Do you think you want IPv4 internet access ready elastic IP addresses attached to every one of your EC2 instances? I would say no, for me, just to kind of answer. So what's the next thing that people generally tend to do, right? Yeah, nay, Robert, yeah. So what's the next thing that people generally tend to do for chopping up their VPC for access, right? Yeah, especially for load balancing. So one of the things that they tend to do is they will actually designate one of their subnets. So I'm just going to do a little bit of hand waving, but one of their subnets, like say this one right here, is going to be considered a public subnet. And then everything, in the back, I'll change the color to orange. This subnet here, I won't go over your text, Matt, they'll say is a private subnet. So then in general, what they do is they say, okay, everything launched in the public subnet and that green dotted subnet, we're going to allow to have internet addressable IP addresses. And you can launch your EC2 instances that way, or you can go ahead and do associations with your elastic IP addresses to your static IP addresses. That's something you can do in the console, or you can do within command line. But now the next step is we're now looking at our VPC in two different ways, right? We're looking at it in a public, and then we're looking at it as in private sections of those ways. And I know that there's, HLST 3ST4 had mentioned something about, is it a good ongoing strategy to do outgoing and incoming traffic to separate them out between things within multiple VPCs? And we'll get to that. And that may or may not help you depending on your business case. But the thing that I would always say as a general rule is whatever meets your business case in the most secure, scalable, and performant manner is probably the best thing for you. And it's not going to be the same for everybody else, right? So even in this paradigm here of having a public subnet and a private subnet, now we're chopping up those two duties of those subnets. That may not be best for a lot of folks, right? You might have, this VPC might be entirely in dev. So we might want to separate out to a multiple VPC situation or a VPC sharing situation. So we've got one more question here from Mohammed. He says, what sort of controls do you suggest we have at the NACL and SG layer when you have all traffic routing through an inspection VPC hosting a firewall cluster? So we go back to the VPC thing. Do you want, I'll address Ken's question too, because it's germane to this, and then we can go into the centralized, because what you're talking about, Mohammed, is pretty much a centralized inspection VPC or security VPC, which is very, very common and used quite a bit. So for Ken, it says, for public subnet, does it make sense to hide the public IPs using CloudFront VPC origin or global accelerator? That's another good question.
I think that's a great best practice. So
Yeah.
hide your instances wherever you can. And if you can hide those behind CloudFront, absolutely do it. I mean, if you don't need folks reaching out and hitting the instance directly and you're using a CDN like CloudFront in front of your instances or in front of your load balancers, that's definitely the way to go. Now, I think on the right-hand side here, I just drew a really quick kind of load balancer topology. I don't know, Jamie, if you want to move over there.
I will move over there. Go ahead, keep talking, I'll get there.
So basically what we've got there is someone on the outside out here that's coming into the VPC via an IGW. They're hitting the NLB first, right? They're actually hitting these virtual IPs. Let me highlight this in a different color. They're hitting these virtual IPs, and then they're going through the NLB and hitting targets. These targets don't need to be publicly accessible, and they shouldn't be. Folks shouldn't be able to reach those directly. And so I think that's probably a first best practice, that hide your instances wherever you can and don't give them public IPs unless absolutely necessary. Now you may say, well, hold on a second, my instance actually needs to reach out. Let's use a different color here. My instance needs to reach out and do software updates or something similar. I need to have public internet access. Oh, that color is terrible. Let's go here and do maybe this one. These instances need public internet access. Well, that's where something like a NAT subnet with a NAT instance can come into play. And so you're actually using NAT or NAT gateway for your targets to, here, if we talk about routing, you have a default route via a NAT gateway, which is this thing here. The NAT gateway has a default route via the IGW, and it also has the 54.10.2.5 public IP to a 10.0.0.25, which happens to be 10.0.0.25, the IP address of the NAT gateway, right? So now you've built a traffic flow. We'll use a different color here. Really simply for inside, I call this inside to outside communication. So inside initiated traffic from a target to say, I need to reach the internet. I don't have a public IP. No one can come from the outside and do outside initiated traffic to my instance, because we're essentially natting everything or patting everything behind the NAT gateway, right? So you've now got this NAT gateway in line. I wouldn't say NAT is a security function in this traffic flow. The fact that your instance doesn't have a public IP is the security function, and the fact that no one from the public internet from outside has permissions to go through a NACL or go through let's draw a security group here. No one can come through that security group from the outside, right? But this instance can go through the NAT gateway, right? So I think the best practice one would be to not use public IPs wherever possible, regardless of the fact that they cost money versus, maybe 2 years ago, they're more expensive now.
Yes.
The second piece would be to think about your traffic flows and separate your outside initiated traffic flows versus your inside initiated traffic flows, and think about what the path needs to be for both of those. So on here again, if I use a different color, our outside traffic flows are actually, let's use a blue, are coming from this X out here. It's initiated from the outside, are going in and hitting the, it's actually there's an FQDN for the NLB, which has two A records, which are this A record and this A record. So you'll get sent to one of these virtual IPs, I guess you could call them, for the NLB, and then down to your instances. So they're reachable from the outside world through a load balancer. The inside initiated, again, follows the green path and says, hey, we're doing a software update or something like that. We go via the NAT instance and then out via the internet gateway and on to our destination for the traffic, so we can suck down the next version of Windows or whatever it may be that you're actually doing, or software or whatnot. So separating your inside initiated and outside initiated traffic flows is absolutely key as well. Jamie, you're feverishly drawing something over there. Should we go have a look what you're up to?
Yeah, I'm just going to go back and I was just kind of drawing up and readdressing what we were discussing about CloudFront and AGA hiding those IP addresses. So I'm just going to zoom out a little bit here, and I was just going to do the dot connecting, if you will. Looks like that looks good.
Before we shift gears, I think we have a bunch of questions here.
Okay,
the
go
one
ahead.
that's standing out to me is actually Hell Upline is saying, if you run one NAT, if that AZ goes down, then your whole internet egress goes down too. That's correct, but it took me a while to get the right mental model around NAT and having NAT gateways existing in a single availability zone. And so when you deploy a NAT gateway, it's AZ bound. That fleet operates in that availability zone. And you might say, okay, I've got instances in that availability zone and they're hitting that NAT gateway. If that AZ goes down, I lose my internet egress. That's true. You also lose the instances in that availability zone as well. So everything in that AZ is actually gone down. So the least of your problems is actually the NAT instance going, or the NAT gateway instance going down. It's your instances are down as well. And so what we'll typically see is folks will build a NAT gateway per availability zone. Obviously, there's per hour charges that are associated with that, but a anti-pattern would be to say, I've got 3 availability zones with 3 fleets of instances, all directed to a single AZ NAT gateway. Because in that case, if that one AZ went down, you would lose internet access, but B, you're also paying cross AZ charges to go through that NAT gateway to get to the internet, and nobody wants to do that. So again, it's the cost trade-off of hourly cost for NAT gateways versus data traffic across AZ, and you should probably just deploy a NAT gateway in every AZ and be done with it.
Right. No, I totally agree with that too. Any other questions?
There's a bunch of questions here. I was not paying attention, so let's kind of go back a little bit and see what's going on.
Yeah. I was furiously drawing. So this is the one where it prompted me to start drawing from TechFuel. Hey Tech. CloudFront option might be better for performance benefits offered by a CDN. That's true, but there are benefits with AGA as well. We'll get into that one. Let me see. Save a bunch of money and run one NAT gateway. That is what you just discussed, and routed to all your other stuff that needs it. It is a pro tip.
Well, let me just come back to that, because I always respect Robert's inputs here, and I think he has got a good point. I just want to reiterate, it's the cost trade-off.
Right.
If you're sending a lot of traffic, you would probably be better placed. Calculate the per AZ data transfer charge, or the cross AZ data transfer charge, and you'll be probably better placed on putting in that gateway per AZ. If you're sending a whole bunch of traffic, then hold on, I think I messed that up. If you're sending a whole bunch of traffic, put one in each AZ. If you're sending a little bit of traffic, you could save on the per hourly charge and just send it through one, but you do open yourself up to the AZ failure. Again, AZ failures are pretty rare.
I'm knocking on
mean,
anything wooden.
yeah, please. I've been around for a while, and yes, there have been AZ failures, I guess, in the last, 12, almost 13 years, but I can't remember any specific painful single AZ failure where myself or my customers have really been hit and we said, oh, that US East AZ failure 1C really took down half the internet. Like I can't really remember any scenarios like that, because I think everyone's building resilience anyway.
Yeah.
And also your internet egress, I would argue, probably, depending on who you are, probably isn't the most important traffic flow that needs to be up all the time from an instance doing a software update perspective. It's really, I'm serving traffic through a load balancer, and that's what's important. And when you've got an AZ failure on a single AZ and it's load balanced, the load balancer just flips to the other AZ for the traffic, right? So that outside initiated traffic is protected anyway, right, when you're serving that data. Anyway, I'm going on a bit of a diatribe here, so I'll
No,
stop.
it's good. One of the things, just to quickly address, like let's say if we had a transit gateway in the mix, right? It is very possible, like this could be, this right-hand VPC right here could be the egress VPC, right? And we have other VPCs that are hanging off to the side with no IGWs. And then we're really only using two, let's say if we put them in here, so two of the NAT gateways, let's put an N there just to mess up our drawing. If we put in two NAT gateways here, we're putting in two NAT gateways for all of our workloads. And we see this quite a bit too, where we'll have maybe one or two VPCs that'll have an IGW attached. And if, I've even seen it with, some V6 scenarios where it's an egress only IGW, right? So for cost comparison and also wanting to keep your HA, it is possible, if you're not slinging a ton of data, to basically say, hey, I'm going to use one of my VPCs or one VPC as my ingress VPC only. I'll put my NAT there. So I only need two. I don't have to put them in every single one of my AZs and all of my VPCs. And I do understand I got that 2 cents per gig, like when I move my traffic from this particular, VPC out, but I'm okay with that because I'm not paying the cost of having a NAT gateway in every single VPC, if that makes sense.
I would argue that this is probably one of the most popular security architectures we see. This is, in fact, we've kind of called it, I don't know if this name sticks or makes a bunch of sense, I guess it does, a centralized egress security VPC.
Right.
And so while you've got NAT instances there right now, and you're saying, okay, well, I'm saving on the hourly charge of these NAT instances, and they're not in every one of those VPCs. It's kind of what we were talking about before. You can also put other network, I call them network functions because they're really instances that are doing things, but they could be applicable to many things. But you're putting other network functions in this VPC, like a network firewall or a gateway load balancer in front of some palos, some checkpoints, or some Sophos or something else, right? You're basically centralizing all of your egress security because you've got that internet gateway here, centralizing that all in one VPC. And you can save a lot on per port hour charges by doing this.
Let's also not forget, one other benefit too. You can go ahead and turn on flow logs, right? And you don't have to have flow logs turned on everywhere. You turn on flow logs on your ingress VPC. So you can also now kind of getting very close to that Ether watch, or the Wireshark experience, you can see all the packets coming in and out. It'll show what's coming in and out of the IGW. It'll even show what's coming through the TGW. And if all of your security play is here, it's not a bad idea to have a mechanism if you don't want to have it running all the time, because if you have flow logs running all the time, it could get quite expensive. But having a mechanism out there like a CloudWatch alarm or something where you see, like, say, a bunch of successive drops on your firewall or on your ANF or whatever to turn on your flow logs and then capture like just about everything coming in and out of that VPC, even east-west inside the VPC, having that all available to you to inspect those logs is a pretty good idea.
I don't know if we would call this a best practice though, right? I'm
Well,
trying
yeah,
to
because
get
that's the
to
thing is,
some clear defined best practices, and
yeah,
like this is just an option, really,
yeah,
right?
it's hard with security and networking when you say a best practice, because networking is not an EC2 instance. It's not like I need, I need more power. Let's get a C5. Networking is like, now I have to re-architect my network to match what my speed is, which may be changing in and out some things. I'm going to use a TGW, or I'm going to go ahead and move to Cloud WAN, or I'm using an NLB, right? And now I need more higher level layer 7 functions for my obfuscation tactic, where I'm going to send everything through a load balancer or through CloudFront or AGA. So, to say something is a best practice depends on what you need to do. A 3-tiered web app, okay, make sure you have internet access coming in. The whole point of your application on that workload is that you're basically taking orders in from your customers. So where's your biggest point of entry? Where's your biggest threat? The threat is the front door, because that's where a lot of your traffic is coming in, which might be completely different from some of our partners, right? Who interconnect, like, say, if we pick on some of our good partners for data manipulation, like Datadog or Snowflake, they use a lot of private link and connect up to a lot of their partners with private link. They have a completely different way of trying to, their best practice is different because there's a different way that their workloads are being accessed. So that's why
Here's a question
it's
for you.
yeah.
And I'm kind of just scanning the comments here as well, and it sounds like Robert has implemented some similar stuff, and some questions about A or B and where that should be located. Can centralized egress VPCs be used in a budget environments using VPC peering? Well, there's actually,
That's a good point.
VPC peering has a problem with this whole architecture. So I'll just describe that first before I get to my question for you, Jamie. So transit gateway, the name transit, it allows you to transit from one VPC to another, but also through a VPC and onwards to other things. And so you can basically have we don't show it here, but let's see what I'm using here. Yep. The transit gateway actually has an attachment inside this VPC. I'm drawing it super mega small, but there's a subnet there for that attachment, and it's an ENI. An ENI for us, an elastic network interface, is really a database pointer, and it exists within a subnet. That subnet has a route table. You're able to then wrap a subnet and a route table around that attachment, so that traffic going from, I'll mess up our diagram here, but going from the TGW through this attachment can then get routed to things. And so by nature, it's transitive. The problem with VPC peering is I'll draw it in green here so we know what we're doing. We have a VPC and we've got a peering connection, PCX. Transit gateway is 2 pennies a gig. Peering in the same availability zone is actually free. And so there's a lot of really good use cases for peering. We mentioned it before, peering doesn't get enough love, but you can't go from an instance here to another instance here with a destination of something outside the instance. You can only route directly to that instance. And that's where I think some of our partners like Aviatrixes and the other folks in the world that use tunnels and overlay networks have found some success in that they'll actually deploy a routed instance here and another one here, and they'll build a tunnel over peering connection and take advantage of peering data transfer. And the tunnel makes it look like the destination is from instance A to instance B, when really it's going to destination C out here, and they do some natting here on the instance. So there are some things you can do with peering, but it becomes far more complicated. And that's why we see people by default going back to transit gateway, because it's transitive by nature, and you can control the routing for the endpoints there. Anything you want to add on this one, Jamie, before we
Yeah, I do. Just, it's
get to my
important
question?
to note too, like when we're talking about, like, we've talked about cost, right? We've talked a bit about best practice to fit business use case. And then even in this scenario, when you're talking about using peering and then having to use an EC2 instance or something third party as a way of getting around the non-transitive nature of peering through 3 different VPCs, just as like Robert has drawn on the bottom here, A to B, B to C, but never A to C, which is a simplified version of what you did. When you're adding those EC2 instances, you're leaving a routing fabric, right? You're kind of leaving the AWS manicured way of handling traffic and going into an EC2 instance using its routing table, whether it's Windows or whether it's Linux or whatever it is, and then going back out. It's important to note, right, that the whole shared security model where we secure things of the cloud and our customers secure things in the cloud. Once you add that EC2 instance, that's your responsibility. So what I'm trying to get at is, like, if it's a Linux box, if it's a Cisco, if it's whatever, you have to make sure it's up to date. You have to make sure that it's locked down, because it becomes, if it's becoming part of your routing fabric, it also becomes a target, right? If I'm a bad actor and I want to get access to something, last thing I want to do is knock on the front door and say, hey, I'm here. I'm coming in. I'm going to huff and puff and blow your house down. I'm going to try to be sneaky about it. And I'm going to look for ways that I can get into your network without you noticing. And honestly, homegrown routers is one of the easiest ways to do it. Linux is great, and it's my favorite operating system. I'll put it right out there. But it has a lot of advance, a lot of tech into it, and there's a lot of different fingers into that pie, depending on where you install it, right? And I'm not saying that people are putting things in there maliciously, but it is very possible that people can make a mistake in code, and then those mistakes get exploited, and then people can go ahead and exploit said mistakes and start looking at your routing tables and doing ARPing and all of that stuff, right? So we need to make sure, Arch, by the way, from Jamie. So we need to make sure that when you're putting in those things, that you treat the security of that EC2 instance, of that NAT. If you're doing Linux NAT even, right? You got to treat that with as much tenacity as we treat the security of the underlying infrastructure that you're running upon. Otherwise, that is your weakest link. So, it's like one of those things.
Yeah, I want to switch gears to Ken's comment, because I think that was referenced earlier as well. Centralized ingress. So we've been talking about centralized egress, and that makes a lot of sense. And I think that, I don't know if that's a best practice. It's just a way of doing things, but it does make a lot of sense for a lot of customers. And we see this a lot. Centralized ingress would be a challenge in that you've got a network load balancer inside our, I don't want to mess up this diagram, but maybe we can delete what I'm going to draw right now.
You want me to move to a different spot?
No, it's okay. We've got a central VPC here for things that are coming in from the internet and hitting a network load balancer inside this VPC. Then you've got some targets that are actually inside an availability zone and a subnet over in this VPC. I'm kind of pointing them into the VPC because the VPC is not big enough, but you're basically using a front-end load balancer to get through to those other targets. I think the challenge with that one is outside initiated traffic tends to be, in what we see, it's not always true, but tends to be far greater than what inside initiated traffic is. Inside initiated traffic is, I need a software update, or I need to get something from outside. The outside initiated tends to be, I'm running a web app, or I'm running some kind of application, I'm serving traffic. There's a HTTP GET request coming in, and then I'm serving a whole bunch of data back out. And with that architecture, putting a transit gateway in line can get very costly very quickly. I think that's probably the main downside of that 2 pennies per gig data processing. There's nothing wrong specifically with this architecture, and I think centralizing your load balancer is totally fair, but the cost of the transit gateway is something I always think about. And so I would probably want to have distributed ingress into each of these VPCs where I'm running an application, but then for specific requests to the internet, try and send that through the central VPC. Now we start getting into split path routing, where I'm taking an internet route via a central VPC, but I'm talking to the internet from a request that's coming through a network load balancer through a directly attached internet gateway, which some security folks may not like. And so there's some trade-offs there and some complication with that architecture. That would be the best of both worlds, though, in my opinion.
Well, let's not also forget, like, one of the things too that is really important is that when you're using load balancers, right? We have three different types really. Four, if you really want to get specific: the classic load balancer, which we've deprecated, the network load balancer, application load balancer, and the gateway load balancer. Gateway load balancer mostly being for firewalls and inspection. But when you're looking at using like the application load balancer, which is layer 7, or the networking load balancer, when you're distributing your targets across a workload, which both the ALB and the NLB are capable of, you also have to kind of switch to how you do your connectivity mechanisms. You're not using, auto scaling and instances. You're going to be pointing to IPs at that point. And if you're really using a network load balancer, you're probably latency sensitive. So you don't want your targets to be on the other side of the map, right? If you're like FinServ or some medical practice that has to respond as fast as humanly possible. So when you're working in security into your conversation of your network architecture, you also have to understand that security, unfortunately, has trade-offs. We've mentioned cost a few times, but the one we haven't mentioned yet is speed, right? If you have a firewall with 1,000 rules and a firewall with 2 rules, which firewall is faster? It doesn't even matter what brand it is, right? It has to evaluate all those rules. And hopefully it has a good way of evaluating it, but that will add some latency onto that conversation.
I haven't done any testing on rule numbers on ANF, on Amazon Network Firewall. I don't know if there's an effect.
The last time I did testing on something like that, I got in trouble. If you guys have ever seen it, there's this cool site. It's a Git repo called Bees with Machine Guns. And what you can do with that is you basically set up a bunch of containers and you can simulate traffic and different traffic patterns. And I was doing that, and I didn't do the thing that we always tell our customers to do, is to inform AWS security first. So if you're doing pen testing, please let them know first. Otherwise, they're going to think you're attacking yourself.
Is Bees with Machine Guns still out there? Because I recommended that to a customer the other day, and I think I was checking the repo, and it hadn't been updated for a long time. But
I mean, quite honestly, what else do you need to do?
For sure.
Yeah, it does what it does.
I think we ended up just using iPerf. I mean, iPerf's pretty much the standard for a lot of this stuff. Yeah.
Did they fix 3? I think you said somewhere that they fixed 3.
They changed 3, so it uses multi-threaded. There's some weird stuff. We should have a session on network performance testing, and then we should test a whole bunch of cool stuff at the time and trigger some tickets.
So one of the things I want to mention,
53 profile sharing. I'm just looking at Robert's question here.
I just want to address.
We might have touched on that with Tom, right?
Yeah.
Anyway, sorry, Jamie, go.
Yeah. I just want to address, like, a while back, Robert or Tech was mentioning obfuscation. I just want to just run through that real quick. CloudFront and AGA. So I just kind of have that up. So what we mean by that, and this is very, very similar to what Matt was also saying too. You can do this with your load balancer as well, where you have a load balancer that basically will place an endpoint, right, that has an EIP out on the internet. I'll just do the XXX. I'm doing it in black so it's easily said, and then say this would be part of the target groups. And then the interaction goes to the load balancer. Let's say this is ALB, right? And then the ALB is basically taking the front end load. You've got your security set up with your listeners. So it's only listening on specific ports. You can even get even crazier with your DNS and Route 53 for resolution for geoloc, saying I only want these particular countries or these particular areas to be able to even resolve this IP address. And then on top of that, you can create an origin for CloudFront, right? I'm gonna make my line a little bit smaller, or a little bit thinner, I should say. And then, okay, and then I'm gonna do this. So then when we're coming through the internet, this is the obfuscation IP address now for CloudFront. And then CloudFront can then also go as an origin to AGA, to ALB. So it's 2 points of obfuscation before you actually hit your actual target. And on CloudFront, you can also have a whole bunch of security mechanisms set in place as well. Geoloc, who I'm listening to, TLS certs, all of that. CloudFront uses physical hardware points of presence all around the internet. And the whole point of that, making that faster, is CloudFront's also directly connected to the AWS backbone, right? So that if it's closer and we put CloudFront in their points of presence in regions or in areas where we don't even have regions, so that the idea is CloudFront will get your customers onto the AWS backbone as fast as possible. Any type of threat surface, even WAF, right, which is available. We didn't even talk about WAF, which is available for CloudFront and for API Gateway as well as ALB. WAF can then evaluate the rules right at the edge, right? Keeping everything off of your back end. And then coming through. So you have the obfuscation, you have the WAF, you even can use Lambda. You have Lambda controls at the edge. So there's a whole bunch of things that CloudFront can do even before the traffic gets to your on-prem. And AGA is very, very similar, but it's more of a TCP thing. Doesn't have WAF or many of that intelligence, but it will still do that obfuscation. You get a set or a pair of IP addresses that are Anycast IPs that are common around the globe, and you can even set up with AGA, geolog, geo-routing, all of that. Again, you don't get that WAF, but it still obfuscates, and then you can make your endpoints either an ALB, an NLB, or an IP address. So that double layer of obfuscation is also very, very helpful. Okay, Matt, back to you.
No, I'm just laughing, and I'm also sad because there's so many things to talk about, and we have 5 minutes left. And we get told to finish 5 minutes early, but we're going to steal another couple of minutes. Okay, I'm just thinking here. I had a question. We can't dive into it now, but maybe we can just talk about it really quickly. Interface endpoints. I think that they are. I would almost put them as a best practice or the best practice around interface endpoints is really we've got public services like S3, DynamoDB, gateway endpoints. And then we've got 100+ other services that use interface endpoints. Instead of going publicly to get to those services, use interface endpoints privately in a VPC. I don't think the best practice is use interface endpoints. I think the best practice is, and you're touching on this too, try and keep things as private as possible. Keep them within your VPC or your VPC area network, and don't go out to the public internet. Don't use public IPs if unnecessary. So I think that's probably a key takeaway as well. There was just a quick question from Mohammed on centralized versus distributed ingress. It honestly depends. It depends on the traffic flows. It depends on your applications. I think there's merits to both in your comment. I don't think there's go one way or another, but do think about cost and going through hyperplane-based services like an NLB and then a transit gateway, or just an NLB, right? I think that's definitely a consideration there. Profile sharing, I think we should do a session on that. Hell Upline did mention around the EC2 instances or instance IP versus IP for load balance. I think that's something to consider around distributed versus centralized architectures. I'm missing a bunch here. We didn't cover so many things, but
we didn't do VPC sharing, and we wanted to, right? We were talking before.
That was the one thing I wanted to talk about.
We have to do another. We should actually VPC sharing is like it should be its own show. There's so much with the paradigms of what that is. But one of the things I think,
and maybe for folks to think about when you're getting started, are you thinking about VPC sharing, or are you thinking about, hey, many VPCs or applications in a single VPC? So maybe a question to you folks to bring your architectures next time on. What are you folks doing?
And we can help you.
Yeah, we derailed the show. Yep.
That's fine. That's fine. Anytime Matt and I are on together, the show's derailed anyways, just from the nature of the two heads being on the same screen. But one thing I want to point out before
first. I want to extend the show. I really do. And Jamie, you do too. We only get an hour, but yeah, voice your opinions, and we would love to have a longer session. Sorry,
we'll carry that back. The one thing I want to say before we are out of time is you'll hear us say this all the time on the show at different levels or different ways, but it comes down to like know your flows, right? So the best practice, the best advice I can give is that the way to find the best practice for securing down your workloads is to understand the flows and then picking out the most secure constructs that match those flows. Just for instance, as you were pointing out, Matt, with private link, if you have a workload that's perfect for unidirectional stateful flows, has to go one direction, and you only want to have one thing calling it and not have the person that you're calling or the workload that you're calling be able to initiate, private link, right? If you're looking at doing something where I need to have very, very specific header manipulation rules or header rules of some data coming in and I need to be transformed to something else, need to have WAF inserted there too. That's my front door, ALD, or ALB is one, or so is API gateway. We have constructs that will fit your flow patterns. And then you have to look at what options you have within each of those services to lock them down better.
I think that's a good closing statement. Hey, can we put our emails in the chat here? You're more familiar with the Twitch training than I am recently. I think if anyone wants to talk about their architectures and if they're okay sharing that. Like you can email us here. I'll put mine here
Yeah,
as well. Please don't be strangers. We love chatting about this stuff, especially in a private setting or you know, talking about customer architectures publicly too. So yeah,
it's
definitely
definitely.
always
I
fun.
think it's our job.
Yeah,
So yeah,
what a great job.
yeah, what a great job that is. But yeah, please definitely reach out and don't
Oh,
be shy.
Tech
What?
Fuel D about missing sessions. We're looking into it.
Yeah,
We're trying to figure that one out. That's a tough one. We're really bummed that we lost a bunch of our pre-recorded content. So,
yeah,
all right. Well, I think that's all we have time for. Thanks, everyone. Great conversation. Loved it.
yeah,
We'll
yeah.
see you folks next week, same time. Thanks, Jamie.
Thank you, Matt. Have a good one.
Bye. All.